Well, hello again. Last time I was stuck on this signal comparator level. Um, so yeah, let's just get right back into it. So yeah, we need to read a value from the input, write one to output G if it's greater than 0, write one to output E if it's equal to 0, write one to L if it's less than 0. I forget what happened last time. So we start with 2. We should go to output G. Yes. Oh. And then it just going through the motions of this. Um. Hmm. I think maybe we can jump to, if we make a label called start here that just loops through the conditions, we can maybe avoid that, possibly, hopefully. Let's try that. Oh, no, that's too early, because we need to move what's left of the ECC first and then go again. Okay, I think it's working. And we should probably do the same for this. After this, oh wait, jump start. So let's move to the right. We do it all over again. And once it's here, we don't really need to do anything else. So it could just stay like that. Let's try it. Okay. 0. It'll move to 1 here, even though it was greater than 0. Because hold on. So we move from the left to the ACC. We check the ACC is greater than 0, less than 0, or none of those. And if it's greater than 0, we move 1 down. If it's else, we... Oh, yeah, I can't even keep checking the number if it keeps moving a new number to the ACC. Unless... Yeah, so... 2. Let's do 2. Yeah, if it's not this, then it'd be this, or then it'd be this, then it'd do its action and move to start again. Right, so yeah, I don't think the issue is with that code here. So it's at 2, move down, jump start, move left to ACC. It's 1, it's greater than 0, move 1 down. Then we have 2, which is greater than 0, move it down. Then we have 0, which is not greater than 0, it's not less than 0. So move it to the right. Move left to ACC. It's not less than 0. So it's equal to 0. So move 1. Oh, okay, hold on. Oh, for God's sake, yeah. It doesn't just cycle through it. It needs to have an output for each individual number. Got it, okay. So we don't have to have this. It can just cycle through all the numbers and just... Oh, for God. Oh my God. Okay. In that case, yeah, let's do jump greater than 0. Oh, actually, yeah, let's just copy paste all this. Nope, my bad. Nope. Okay. Copy, paste. And we don't need these star variables. Or labels, I mean. Oops. Okay. ABC, if it's A, move 0 down. Oh my God, come on. Move 0 down. Just do everything and then move it to the right. This was much simpler than I thought last time. Unless I end up doing it wrong this time again and I'll look like an idiot, but we'll get there when we get there. If it's equal to 0, so... Nope. 1. Nope. 1. Down. And then it doesn't need to move it anywhere else. So I think we're good. Damn it. Okay. 2 is 1, 2. No, come on. Right. I can't just keep moving. 0. One down, move it to the right, move it to the... Maybe, yeah, maybe I am overcomplicating this. If it's greater than 0, move it down, otherwise... just move it to the right. Okay, move to the left of the ACC, we check if it's greater than 0. If it is, we move 1 down. If it's not greater than 0, we just move it to the right and keep going from there. I think that's the way to do it. this is checking if it's equal to 0. So yeah, we would have to check less than 0 first. And if it's not, then we move it down. If it's less than 0, we if it's less than 0, we move it to the right. Otherwise, we move it down. Okay, so we take in this number which is not greater than 0. If it's less than 0, we move it along. Otherwise, we move 1 down. But we need to jump this. Yeah, okay, we do need a start label. So that way, if we're moving it to the right, we start all over and take in the next number. And we don't move. We move 0 down. Move 0 down, then move it to the right. Nope. Crap, what was that? That was B. Okay, I think this makes sense. Hey, let me... Okay, so we start, we take in the number from the left and put it to the ECC. If it's greater than 0, we go to A, and move it down. After we move it down, we want to go back to the start. Let's just add some spaces in here and make it easier. So we start, move the number from the left to the ACC. If it's greater than 0, we move 1 down and restart and go with the next number. If it's not greater than 0, we move 0 down, move the number along, and then take in the next number. And same here. Move number from the left in. If it's less than 0, we move 0 down, we move it along, restart. If it's not less than 0 or greater than 0, it means that it is 0, we move it down, and then restart. I think this makes sense. Let's just do A and B. I'll need to be more descriptive with my labels eventually, but for now, since I have move here, I may as well move. If it's greater than 0, we move 1 down. If it's... Well, if it's in here, we know it's greater than 0. So we can just move left down. I think this is the solution. Until then, I'm gonna... But before I do, I want to read this. I found a block of static memory, but it's... Oh, I already read this last time. Yeah, some weird memory in the system. Yeah, so this is just a weird system. That's all we know so far, as far as the lore is concerned. Hmm. Oh. Move 1. But then how are we moving 0 down? Okay, let's just... Nope. Okay. God, I feel like I'm just missing it completely. I think I know what I'm doing wrong. Once it's moving down, we just restart all over and we don't move the number along. So yeah, it's the same issue as last time, where I need to have an output for each number. So we can move ACC to the right. It's greater than 0, we do that. If it's less than 0, we do that. So this one we need to check if it's greater than 0 or less than 0. Right. Yes, that makes sense. A. Nope, just A, B, and that'll be good from there. Or if it's neither, then we'll move it down. Oh, this is probably super frustrating to watch, honestly. So if it's greater than 0, move 0 down. And then if it's less than 0, we move 0 down. Oh, man, we're almost out of... Damn it, we're almost out. See, maybe I can just get enough. Move 1 down. Start. Nope, jump start. Okay, if I'm correct, it's gonna, once this number is here, it's gonna move left to the ACC. We're gonna jump to A if it's greater than 0. If it's greater than 0, we check 1 down. We move the number along and we read the next number. If it's not greater than 0, we move 0 down, we move it along, and bring in the next number. From here, bring the number in. If it's less than 0, we move it along and mark 0 down, restart. If it's not less than 0 and it's not greater than 0 here, do I need to check if it's greater than 0? I only need to check if it's less than 0, right? Yeah, I only need to check if it's less than 0, because this will take care of if it's greater than 0 or it's equal to 0. If it's less than 0, we move it down, move it to the right, jump start. If it's... No, I do need to check if it's greater than 0. So if it's less than 0 or greater than 0, we just move it along. If it's neither, we move 1 down, move the number along, restart here, take the number in, we check if it's greater than 0 or less than 0. Right. we would only need to check if it's less than 0. Because if it's not less than 0, it's either greater than 0 or 0, so we can just jump. If it's less than 0, if it's less than 0, we have to move 1 down. Anything else, we have to do 0. And okay, so these two are fine, I think. We'll take the number in. If it's less than 0, move 1 down, restart, and I think, yep, okay, there we go. Oh, I apologize for that. Took more cycles than oh. So I did pretty terribly on this. That makes sense. Okay, let's keep going. Signal multiplexer, which it being a multiplexer, we're taking in one input and making it many outputs. So we want to aim for what, like 250 cycles, very few nodes, and very few instructions. Let's go. Let's see what's here. I might have an idea of where this TIS-100 machine came from. Someone described the architecture to Fred at Motorola, and he said it sounds like it was designed for signal processing. That got my brain going. Government project maybe. Something the CIA cooked up to comb through Soviet radio signals. Hush hush, top secret. Maybe could I be in possession of a classified device? Something for spooks? I might have to sit on this one for a little bit. Interesting. Oh, yeah, I had the multiplexer all wrong. Many inputs to one output. Demultiplexer is one input to many outputs. Read values, read value. A and B. Right. So right when it's -1, when it's 1, right in A plus in B when it's 0. So we're reading it, but we're not right. Oh, I know. We can move it to down, so it'll be here, and then if this is, let's say -1, we'll just add it to AC. We'll move from down ACC. Okay, so we'll move this down so it's in this little boundary area. We'll move, let's move this to the left. And we'll move it to the right, so it'll be here and there. I'll start with input A. We'll move from the right to the ACC, and if it's less than 0, we'll move our input to the ACC. Wait, we don't even need to do that yet. It'll stay up there until the next number comes along, or until we write this number in. So, okay, so we'll move it to the left. Move to the right to ACC. If it's less than 0, we write. Otherwise, we'll just go to the beginning, I guess. Let's see. Oh, right, because there's nothing down. We have to move it from up. So we write after we write, we Oh, for God's sake, no. Writing it is sending it to the output. That's dumb of me. So we're writing input A when INS is equal to 1. So we could probably transport this down to the output to check. And then if it is, then we can do the math of these two numbers here. So we can, yeah, okay, that'll work. Move up, down, move up, down, move up, ACC. If it's less than 0, A, we'll write A. If it's greater than 0, write B. If it's neither, then we write the sum. A, move left, down, because that'll be input A. B, move right, down. C, add left, right. Oh. No, we would have to add one of them to the ACC. Add, oh, move left ACC, add from the right, move ACC down, and then we'll go back up. I think. We'll just have to see. So, yeah, I guess, yeah, it'll have the instruction, move down, go to the ACC, go through all these conditions, it'll move the value. So, yeah, we don't even need to move to the ACC on any of these. Alright, because once it does that, it needs to move back up, so let's just simplify these lines a little bit. Needs to go through the loops again. No, we would need two. We would need two loops. We would need a start loop and a check loop. So once it goes through all the instructions, move left down. No, it'll already be checking all of this. Nope. I wish I had more insightful commentary to this, honestly, because I started this channel trying to play games from like an electrical engineering perspective, give some insight, but this is stuff I'm completely unfamiliar with. So I really don't have that much for you. And I apologize for that. Otherwise, if you just like to see how I do this, let me know. If you want me to think of just something to say in between, let me know. Just let me know how you're feeling about this and what you'd like to see from this specific series, because I'm probably not going to be able to do much teaching or explaining of the concepts behind this, unfortunately. Other than the obvious, like assembly language is like a step of abstraction above just pure machine code, which is just binary digits through the ALU. And yeah, we're just writing instructions from inputs to addresses in these nodes, or to memory, and then to an output. But yeah, other than that, I can't really go that far into depth from it because I just don't know. It's -1, which means we read from that, go to the start. It's 1, it's greater than 0, so you move right down, move 1, move right down. So that's why, if it doesn't bring these inputs down, it just holds there. So you can probably bring it along when it skips its loop. Let me pay attention to this side. 7 goes down. 7's on the left. It's running through this. It's -1, so we move from the left down. Jump start. Next instruction is positive, so we're moving it from the right. But nothing was here, so it just defaulted to its previous value, which is going to be wrong. Hold on. 7 travels down. 7, so there's 2 7s, 1 6. it's just going sequentially through the two sevens. Well, it's 1. Starts with 7, 7. Now it needs to go to 6. But it won't. 7, 7, 7. It's negative, so it chooses 13. Then the next one is 7. So that's what it chooses. Yeah, let's remove this instruction. And let's try it again. 7 goes down this way. It's compared to 13, but it's negative 1, so it chooses negative 13. Go back to the start. Move this instruction down. Yeah, the 7 just stays there. Yeah, if it's not moved, it just stays. So at the start again. Once this node is filled, then this instruction is free to do its operation. So how do we take care of that? We could move to the ACC first, but then we have to move it to the left anyway to check. If we move to the ACC, then we move it left, then we move what's next to the ACC, then left. I think that would work. Let's check it. Oh, not to the left, to the right. My bad. Damn it. We could reset 0 on this side. No, because that would be here. So when it's reading from here, we need to reset the left and the right. This logic is fine, it's just not reading these correctly because the logic here is wrong. Let me try that again. 13 comes in, move left to down. Once it does that and jumps back to the start again. Yeah, so left has been moved from, so the number on the left has been moved down, freeing up this node to go through its instructions again. But the same thing is not the case for this. Perhaps if we know that what the instruction is going to be beforehand before it reaches this node, for instance, if it's -1, we can set this to 0, or we can just keep it in a loop until it's -1. Yeah, if it's -1, do nothing. If it's 1, move it down. Sorry, if it's -1, do nothing. If it's anything else, because when it's 0, it needs to be moved down as well. I think that would work. Move up, down, move up, left, move up, right. Why is it not? Oh, right. Okay. Let's try it again. So in these nodes, I want to check the instruction first to see if it's, for input A, if it's -1, so long as it's not greater than 1. Keep moving it forward. So move left ACC. Let's see how that works. Oh, right. Right, because there's no left. It's right. And we're moving left here. So we got that instruction. Let's start with input A. If the instruction is negative, keep it moving along. Otherwise, if we're not moving it, just hold it there. Just jump back to the start. Let's see. Yeah, how did it freeze up there? Move it down. It's frozen up here. Right, there can't be anything moved because there's nothing to check here. So, yeah, these nodes are frozen up, and then we can move ACC down, down. And then it's frozen here because there's nothing on that side. So yeah, move left to the AC. Yeah, let's do the same thing here. Start, move left to the ACC. If it's greater than 0, we move down. Otherwise, go to the start again. That's going to be an issue when it is 0, though. Scan 0, move it down. So for both of these, if it's 0, it just cycles through forever. What is going on here? Just doing the same thing. I brought this. Where's that 6 going then? So 7. So moves down. Right. So moving this to the ACC, then moving it left. But if it never gets read, it stays the same number. We want it to delete itself and move on to the next. No, come on. 7, go down. It's red. 7 comes back. The instruction is 1. I think, with all these instructions, it's delaying the correct inputs from coming down. Or maybe, I don't quite know what I'm doing wrong at the moment, which is an issue. And I bring 7 along because it's still between the nodes. So how do I get rid of that 7 and skip to 6? Travel down. Bring 13 down. And 7 is correct. No, we need to bring them both down at the same time and check against and then somehow get rid of this number. Yeah, because once it's in ACC, then we need to check and remove that number if the condition doesn't work. So we can do that here. So yeah, we can move this to the ACC. If it's greater than 0, we'll move it down. If it's not, we move 0, move up, down, move. No, we need a delete function. We remove that number to the ACC and then move 0 to the ACC, and then we go again. And move up, ACC, move 0, ACC, and then we restart. So theoretically, what's going to happen is going to check the instruction from input S, and if it doesn't allow the number to move forward, in order to free up the pathways, we're going to move that number along, delete it, and only pass a number that works. Probably not going to work. 13 is down. Where did 17 come from? Where did 17 come from? There's no 17. Oh, from input B. Oh, God. Yeah, this is like so much further ahead. So the input instruction is -1, which means we go with -13. Move that along. Right. Move that along. Go to the start. New input instruction is 1, which means we bring down 7. Right. Where did 6 go? 7, 7, 7. Where'd 6 go? Nope, sorry. 7 goes down. 7 gets deleted. 7 comes down. 7 gets passed along. 6 comes down. Wait. When it's 6, it should pass through. So -1, 13 is going to pass. 7 is going to get deleted. Now it's 1. Which means we move it down. 7 gets passed through to output. Oh, I missed 6 again. Where did 6 go? Seven again. Okay, 6 is here. Moving ACC to the left. God damn it. Yeah, as this is happening, it's still... Right, because it's not going back to the start. It's just passing through. We gotta add that in too. Let's try it again. 7's gonna get deleted. 7's gonna pass through. 6 should pass through. Yes, it is. Good. And now it's idling because the ACC is 0. So when it's 0, okay, it's greater than 0, delete. Otherwise, bring down. For input B, only delete if it's less than 0. For input A, only delete if it's greater than 0. Otherwise, bring it down so that they can be added together at the end. There it is. This is probably incredibly inefficient, but it works. Oh my god, I was worried I was going to have to end this off before I could finish, but it's working. I'm seeing all these idle times. There's probably a way to make this way more efficient, but... I mean... Oh my god. Oh god, I'm terrible at this. Well, yeah, we're just coming up on an hour now. I don't want to start another one if I won't be able to finish it in 5 or 4 minutes now. So yeah, I hope you enjoyed this. And yeah, as I mentioned before, I know my commentary is probably not going to be as informative as at least I attempted it for my last series on NAND game. So yeah, just let me know how you're feeling about this so far. If you care enough to let me know. But yeah, otherwise I'll see you in the next one. Have a good one.